So myself again, B. Kashinath, working in Government Polytechnic Sangareddy, senior as a senior lecturer in Electronics and Communication Engineering, and the subject is Electronic Measuring Instruments, and it is elective. It is in third year, fifth semester. Subject code is 18EC504EMI. E stands for elective and first elective, so it is A. So and the topic is the third chapter, digital instruments. In that one we are going to discuss about the specifications of the digital voltmeters. So in the previous class we have discussed about the advantages of digital instruments over the analog instruments. So in this class we will discuss about the specifications of the digital voltmeters. So on completion of this period you will be able to know about what is 3.5 digit display, resolution and sensitivity of the digital voltmeter, and what are the different specifications of the digital voltmeter. So digital voltmeter is a versatile digital instruments. So in digital instruments we will be having for measuring the voltage we will be having the digital voltmeter. For measuring the frequency we will be having the digital frequency meter, and for measuring the different components like inductance, capacitance and resistance we will be having the digital LCR meter, and for checking the IC integrated circuit it is working or not we are going for the digital IC tester, and for checking the microprocessors and microcontroller signals of that are working we are going for the logic analyzers, and for checking the measuring the values of voltage, current and the resistances we are going for digital multimeters. So and the versatile instruments for measuring the voltage across different devices, that is we have to measure the voltages, so we are going for the digital voltmeter. So in that one what are the different specifications of the digital voltmeters, and these digital voltmeters are broadly classified into four types depending on how they are measuring the voltages. Based on that they are classified into a ramp type digital voltmeter, and second one is successive approximation type digital voltmeter, and third one is dual slope integrating type digital voltmeter, and fourth one is continuous balance type digital voltmeter. But in our syllabus we will be having the ramp type digital voltmeter and successive approximation type digital voltmeter. That construction working we will see in the next class. Today's class we will see the specifications of this digital voltmeters. So what is 3.5 digit display, what is resolution, sensitivity and different specifications. So 3.5 digit display means, so we will be having the 3 digits full display, and half digit corresponds to either you can have either 0 or 1 on the digital voltmeter. So the total the number of digit positions used in the digital meter determines the resolution also. So hence a 3 digit display. So you overall you will be having the 3.5 digits. So on that 3 digit display on a digital voltmeter of 0 to 1 volt range can indicates the value from totally how many values you can have from 000 to 999, so that you can have 0 to 1 volts. If you want to measure you can measure from 0 to 999 millivolts up to 000 millivolts to 999 millivolts on a 0 to 1 scale. So you can measure 50 millivolts, 100 millivolts like that. So it is having the high resolution, means on a 0 to 1 scale if you are having 3 digits you can have 0 to 999 millivolts. If you are having 4 digits you can have 0 to 49999 millivolts like that. So and the fourth digit is only capable of displaying the 0 or 1, that's why it is called half digit display. So it is placed to the left of the display, which can be used to have only either 0 or 1, so that you can increase the range of these measurements by 0,999 to 1,999. So it can measure from 0,999 millivolts and beyond that 1,999 millivolts like that. So fourth digit permits the digital meter to read the values above 999 up to 1999. By the use of off digit, you can have in the top digit either 0 or 1, so it can increase the measurements from 999 to 1999. So this type of display is called 3 and half display. So that is display, so it will be looking like this. You can take the screenshot or you can note down. So you are having the 7 segment displays. So these uh, these three are full digit, which can represent from 0 to 9, and the left digit is only half digit, which can display only either 0 or 1. So that if all the 4 digits are zeros, means you can measure from 0 0 0 0, and the first digit is 1, and these 3 digits maximum value is 999. You can have 1999. So if you are having by using of this off digit, you are increasing the range from 0 0 0 999 to 1999 by using of this off digit display. You can take a screenshot or you can note down this diagram of the 3 and half digit display. So now comes to the resolution and sensitivity of these any digital meters. For every free digital meters, we will be having this resolution and sensitivity. So resolution is number of full digits. If n is the number of full digits, that is, if you are having 3 and half digits like that, you will be having 10 digits or 4 digits or 5 digits for the display. Then the resolution is given by the 1 by 10 to the power of n. Like suppose the resolution of digital voltmeter is determined by the number of full or active digits. In previous case, the number of digits is 3 digits, so you will be having the 1 by 10 to the power of n, that is 1 by 10 to the power of 3. You will be having the 0.0001 up to, you can measure up to 0.000001 change in the measurement. That is, in terms of percentage, you will be having the 0.1% minute change can also measured by your digital meter. You can take the example. And sensitivity is the smallest change. Sensitivity corresponds to smallest change in the input which a digital meter is able to detect. So smallest miniature change that happens in the input that can be detected by your digital meter is called sensitivity. It is the full scale value of the lowest voltage range multiplied by your meter's resolution. So sensitivity is given by the whatever your full scale value, that is of lowest range, and multiplied by your resolution. So Fs minimum is the lowest full scale of the meter, that is multiplied by your resolution. Fs minimum into R, that will gives the sensitivity. So we can take a example for this. So what is the resolution of 3 and half digit display on 1 volt and 10 volt ranges? So how many digits are there? 3 digits. So therefore the resolution is 1 by 10 to the power of n, where n is how much? N equal to 3, because 3 and half digits, you can omit only 3 digits. So the resolution is 1 by 10 to the power of 3.001. And in case of 1 volt range, 10 volts range, how it will be? So on full scale range of 1 volt, the resolution will be 1 into 0.0001. You can note down these values. So here you see, so the resolution comes by digits, that is 1 by 10 to the power of n. So that is 0.001. So on a 1 volt scale and the 10 volts range, we will see what happens to our this one. So on a full scale range of reading of 1 volts, the resolution is 1 into 0.001. So it will be 0.001 volts. For full scale reading of 10 volts range, now the resolution is 10 volts into 0.001, so 0.01 volts. Hence the meter cannot distinguish between the values that differ from each other by less than 0.0001 of full scale in case of 1 volts, and in case of 10 volts range it cannot distinguish between the values that differ from each other by 0.01 volts. So that is the difference. And the specifications, coming to the specifications of digital voltmeter, and the display is how much, 3.5 digits, and the display is of what type, LCD display. So by using 3.5 digit display you can measure from 0,999 to 1,999, so all zeros to 1,999 millivolts, like that. And the input range from plus or minus 1.000 volts to plus or minus 1000 volts with automatic range selection and overload indication. Overload indication also displayed by your digital voltmeters. So input range can be from 1 volt to 1000 volts, that is plus or minus 1 to plus or minus 1000 volts. And the overrange indication, it will be displayed either plus 1 or minus 1, that is displayed at the MSB position of the that off digit display. So off digit, it is 1 or minus 1, then it will say that it is whatever the measurement is over range. And the absolute accuracy, it is as high as plus or minus 0.00005% of the reading. Accuracy is how much, plus or minus 0.005% of the reading. And stability, stability comes for short term and long term. So short term stability for short duration, long term stability for the long duration. In that case you will be having 0.002% of the reading for a 24-hour period, and for long term it will be 0.008% for a reading of over a 6 months period. So you can change of the value that you can measure is 0.002% after 1 day. If you are measuring the same value in case of long term, after 6 months the measurement value can change up to, by only 0.008% of the reading after 6 months. And the resolution is 1 part in 10 to the power of 6, means you can have 1 by 10 to the power of n, where n equal to 6. So you can measure up to 1 microvolt can be read on the 1 volt input range, so that you will be having the means 0.000000 microvolts to 0.999999 microvolts. That is, you can have reading in not in the case of millivolts, but you can have microvolts also, means even a micro 1 microvolt change in the deflection on the digital readout can be easily detected by your digital voltmeter. And the input characteristics are, input resistance is typically 10 mega ohms and input capacitance is 40 picofarads. And the output signals, so it will gives the print command, allows output to the printer, or BCD output for digital processing or recording. It will give the BCD, binary coded decimal, that you have already studied, binary coded decimal output for digital processing or recording. And the zero adjustment is automatic. And functions, you will be having different functions that are displayed on your digital voltmeters. Are you can have DC volts, AC volts, DC amps, AC amps, ohms, and diode test. These are the different functions on the specifications of digital voltmeter. And manual is switch selection as desired. You can manually select the switch selection. Temperature, operating temperature range from 0 to 60 degrees with a relative humidity of 70%. And polarity, auto negative polarity indication it is having. And low battery, it is indicated by B mark on the LCD readout. On the LCD readout, if you are having seeing the B, then it is showing that it is having low battery condition, and the power supply is 230 volts 50 megahertz. 230 volts 50 megahertz is the power supply for the your digital voltmeter. So in this class you have learned about the what is 3.5 digit display. So 3 digits for full readout, and half digit only display only either 0 or 1. So you can increase the 0 to 999 to 1999 like that. And what is resolution, what is sensitivity of the digital meters, and what are the different specifications of the digital voltmeter. A simple quiz. The short term stability for a period of 24 hours of a digital voltmeter is how much? So from the specifications, is it 0.002%, and the long term stability is 0.008%. A digital voltmeter of 3.5 digit display can be easily display up to how much values? 1999. It can be display up to 1999, that is 1.999. So frequently asked questions in this class is what is meant by 3.5 digit display, and list the specifications and define resolution and sensitivity of the digital voltmeters. So thank you one and all.